can have strictly equals.
No, there's not an easy way to do it.
Because you can have two different variable types that are equivalent, like a string that says 101 and a integer that says 101, and they can be equal but not really. Like it's the same thing but it's not. And equals equals in, I believe in Java, will say, yeah, that's equal, that's fine. But the 3 means that it has to be the same type of, you know, it has to be an integer to integer 101 equal to 101. Like it has to be the same type. So I do believe that is self-destruct in C++. I'm pretty sure the program will implode if you put in 3 equal sign.
So we have car, and then the name of our car, we'll say car. Then we'll do the equal for assignment, and we'll just say new car. This is creating a new instance from our blueprint, it's creating a new object.
It's a weird concept. When I first saw it, I was like, strictly equal? I thought that was what that was for in the first place.
Kind of go through all this
I was
stuff.
wrong,
This
Joe.
is a bunch of given methods for any object, but we actually created a custom one called print variables. We'll hit enter. There it is. And now we can run our first application. Very exciting. And so we'll do Command S to save. We'll run it by clicking this little arrow up here, the play button. And so we'll run it. And down here, all of our things are what they're supposed to be. If you look up here, our max speed matches up with this. Our 0 matches up with that. And to prove these are actually printing out like they're supposed to, we can add a little note here.
I'm not gonna lie, I'm already just ADD'd the F out on this video. How much longer do we have? But we're doing this for the people. We're doing it for the people. We're not doing it for ourselves. We're doing it for the Twitch audience, which oddly enough probably knows more about programming right now than I do, that being hyper. And for the YouTube audience that will watch this later, because I will be splitting this up into smaller videos, like 15-minute videos, so that other people can walk through with us.
Okay, print this out, and then the next thing you print out, we're going to do it on the next line. And so that's printing things in your console. Again, super useful if you want to know what the values of your properties and fields are. So besides primitive types, there's another type of data type that is out there.
Another type of type?
It's called a reference type. And a reference type does a shared copy. So say you have a car that's shared by multiple owners. Each time you reference the car from any of the owners, you want it to be the same car. So say one of the family members paints the car blue. Well, when you access it from a different family
better have been the
member,
parents
you
painted it
want
blue.
to be blue. Because someone else changed it, it's the same instance.
Yeah, for sure. It's definitely, they're definitely going to be those 15-minute, just quick videos where you can peek at it, you know, kill some time, maybe take a break from work, and then come back later, watch another one, so on and so forth. Because this 24-minute video that we're watching is definitely going to be split into 2 videos on our channel, because I can't even.
And so we can say car, Alice car equals family car, because her car is the same as the family's car. Now let's change something about the family car. We can create a new method or function here, and just follow along. We'll talk more about functions later, but we can say public void change condition.
And just a reminder to everyone watching this later, she is using JavaScript currently. She's just showing us examples in, not JavaScript, Java. Bleh. Bleh. Innocence of the mouth. She's using Java to show. It's very similar to C++. The syntax is different, obviously, but it's still going to be a similar concept. All the concepts are pretty much the same. If you look at the syntax, it's even pretty similar. It's, you know, you got your squiggly brackets, you got your, you know, the comments are the same, the, you know, the functions are named a little differently, but that's fine.
And we can see if Alice's car has been affected by this change. What should happen is because a different family member wrecked the car, Alice's car should have the condition C as well. It shouldn't be A, it should be C because
somebody's in
car,
trouble.
which is the
Someone wrecked the car.
got wrecked. And just to make this a little clearer, we can add a system.out.println, and then you can put a little note here that says Alice's car. So it's easier to read in the console which set of variables is Alice's car. And we can also add it up here to system.out.println, and we can say family's car.
Yeah, that, well, yeah, I agree. It's higher level, but it's not. I don't know. Like learning Python is 100 times easier than learning C++ or Java. You know, learning like Ruby or any of those what I would consider very high level languages are easier. I feel like JavaScript, because of the syntax and the way things are laid out, that it is fairly easy to learn, especially compared with C. Like just regular old C. Like C has been something that I've been messing with for a while now, and it's kind of hard to learn on your own. And Java is everywhere, so a lot of people prefer to program in Java because it's run in a virtual terminal on any computer ever. Well, not any computer, or ever. Like you can't run it on an Abacus. Abacus doesn't have like the right outputs, so.
Equals max speed plus 1. And so what should happen is min speed gets the 100 from max.
You're right, Hyper. It is a little bit easier to learn, but I think it's pretty close comparatively speaking. A lot of the concepts are the same. Java does have a huge leg up on libraries though, like not having to repeat code. Oh my goodness, so much more intense on the Java level. C++ is not. At least as far as in my experience.
And notice the first time we do it,
everyone has their own thing.
But when we do it the second time, here, the max speed is 101 and the min speed is 100. So it worked the way it was supposed to. If this was with references, then the min speed should be 101 because here we changed the max speed. But that's not the case because this is a primitive data type, and these variables are completely independent from each other. But notice when I changed things with the family car, it also changed things with Alice's car because it was referenced. I know this may seem super abstract and kind of out there and not really important right now, but it is really important because when you start changing things in your code, knowing if something is a referenced or primitive data type can help you avoid mistakes and avoid changing things that are linked to other things that you may need later and not want to change.
Yeah, no, that's true.
Reference types are actually
as long as it can run the Java virtual machine.
Stacks. You may not know what those are right
which
now.
is pretty cool. It really makes it, what am I trying to say, independent of any particular operating system. So they don't have to bow to Microsoft or to Apple or to, well, no one really bows to Linux. I love Linux, but no one really caters to the Linux crowd. Not yet. Someday.
And so we'll say string with an uppercase, and we'll say name of car, because it's going to be the name of our car, equals, and then we'll say Lucy. And we'll do it with double quotes, because a string is with double quotes, a character is with a single quote. This matters in Java, but it doesn't matter in some other languages. So we'll save. A reference type works just like a primitive type. And here in our print variables, we can just add system.out.println, and we can print out the name of our car. So we can just say name of car, add a semicolon, save, print it out, and Lucy is right there. So in this video, we talked about data types, reference versus primitive, ints, bools, floats, doubles, characters, strings, all of them. very exciting. And we also played with printing into the console as well as with a couple methods. So thanks for watching this video. I hope you learned something new and that it wasn't
I think more people cater to Microsoft than they do to Linux. Like Linux requires certain things, and they are powerful enough for those requirements to have to be met. I don't know if that makes any sense. Linux doesn't have that kind of power. Linux has like very open mind towards new things. I mean, people who use Linux generally like things to be open source or whatever, but you don't have to do that. Like I used closed source drivers for my AMD on Linux, but if I wanted to use, well, Linux is for advanced users, but, and it's not really, because Linux Mint, Ubuntu, those are two I can name off the top of my head that are actually frighteningly similar to Windows in the ease of use category. If you were only a person who needed, like, you know, text, you know, what am I saying here, like for schoolwork or whatever, Linux would be just fine. Because if you're trying to game, obviously you're going to want Microsoft because it's got drivers built in for all kinds of shenanigans, and it doesn't require the command line to install certain things. But yeah, I think you're right. Linux is more like Linux is for like advanced users. If you're using like Debian, you know, or Red Hat, even the enterprise version, that's still very, like, that's very advanced stuff. But just think about it. It used to be the other way. It used to be command line was, you know, for everybody, and then the GUI came along. So anyways, getting distracted. Alright, so data types, we got primitive data types. They're independent: byte, short, int, long, float, double, boolean, and char. Most of those are numbered. Alright, so integers are your whole numbers, I believe is how it's referenced. And doubles are your numbers that none of us like to use in school. So it's your decimals. Alright. Scanner, I don't even know. Okay, that's not really too useful for us. Oh, this is gonna be where it gets interesting. Into the last line, and blah blah blah. Next line. Alright, C++. Here we go. So you have getLine, right? Eat white space. White space is delicious. Alright. So what is it trying to tell us here? S2 is a string. In addition, you guys specify scale of floating point following code. Okay, so scale, right? Set precision. Okay, so you have this double, it's pi. Double pi. So extra pi. Now let's say you don't need these last three, right? I gotta turn my DPI down. This is insane. Okay, 159. You don't want that. You don't want it. You're done with it. You don't need it. I don't need it. All right, so we're gonna go to output, right? And we're gonna say, hey, we want it fixed because it's not the way we want it. It's a way of thinking about it. All right, set precision. All right, this is gonna set the precision for, I believe, every double after this line of code. So any double that gets posted until you get rid of precision is going to be to a precision of 2. Well, yeah. Float is more precise. It goes out more places. But if you were trying to describe pi in depth, you would definitely use float. But I don't think that's the intent with this particular thing. So, and then you set the precision to 2. So it's going to knock off everything. It's not going to round. So don't think that. If this was a 9 right here, it would not become a a 5, it would not be 3.15. It just eliminates everything after the 4. So when it prints, it's only going to print out 3.14. Easy peasy, lemon squeezy. Right? Alright, so hey, let's review fixed, because I feel like I did not explain that very well. And wait, printf? Like, who uses printf in C++? Anyways, ruh-roh.